Hello, in this video I'm going to go through the Arkansas Tech University IEEE robot we made to compete in the 2025 Region 5 IEEE robotics competition. It was in Wichita, Kansas. And first I'm going to kind of go through the rules of the competition. So here we're given an 8x8 field, and these red squares here indicate a fire location. And the robot has to autonomously navigate through this 8x8 field and find which corner has a fire. And we do that with a temperature sensor. But there could be obstacles, and so the robot has to know how to autonomously navigate throughout everything. The scoring for the competition is based on the closeness to the fire and then the closeness to the return position. So here I've got the scoring bands where you can see the closer the robot is to the fire location, the more points you get, and then also that same scoring band is used for the return position. So our robot uses ROS 1. We're using an NVIDIA Jetson Nano, and it's equipped with a RP LiDAR A1 for its navigation, and also a BNU055 gyroscope to help localize itself. It is also equipped with motors with encoders, and those encoder values are being read by an Arduino, which then publishes to the Jetson so we can get the robot localized. So I've got kind of a demonstration here. The first thing I'm going to do is I'm going to set the pose of the robot. So the robot, as you can see in the bottom right, it's facing that direction. And so when I do that, you can see it localize itself. And that red you see there is the active LiDAR scan. So the first thing I do when I run the script to run everything is I run over and I place an obstacle live. So you can see in the bottom right there, I place that obstacle right there, and the robot has to stop and think and go around it because it's not just static, it updates to live changes. So what the robot's doing now is it's going to check every corner to find which one the fire is in, because it doesn't know. The fire is in this top left corner here where that heat pad is. So here it gets to this first corner and checks. As you can see there in the console, it gets a temperature of about 71, so it knows the fire's not there. It then changes its path to go check this top left corner, which the fire is actually there. But it has to autonomously navigate through these obstacles as it goes. So as you can see, that orange line there is the path it wants to take. So there it kind of did a 360 to kind of reorientate itself because it knows there's an obstacle there and it knows it can't run around it. But eventually it'll figure out how to get around it. So there it goes. And then from there it's got pretty much a straight shot. So it gets to the fire here, it gets pretty close, so we get the maximum amount of points, and then it performs a sweep to like a 15 degree in both directions to kind of make sure we don't miss. Here it's actually spinning in a circle because it's trying to get really close to this this goal we gave it, and I think it kind of undershoot it there, so it had to kind of slow down and back up. But once it gets realigned, it's going to go back forward. Yeah, there we go. And it gets to that position, and then bam, you see fire detected. 126 degrees, so we know that's the fire location, and so then it sets its path back to the initial start. We actually started in that bottom right corner there where the blue lines are, but for scoring, the robot needed to be back in the original scoring bands, so it doesn't actually navigate all the way back to that corner. It kind of stops where those white lines are because that's where we're being scored from. So there, there were some obstacles there. It had to figure out how to get around, but eventually it does, and you can see that path actively updating. And then once it gets clear of the obstacles, it knows it's pretty much got a straight shot, and it'll get in that corner. And then once it's there, successfully returned, and that's pretty much it.